All right, and this brings us to our last section of chapter 1. So this is section 1-8, and it's perimeter, circumference, and area. All right, so let's quickly review. So let's cross out the shapes that are not polygons. So if you recall, polygons are closed figures with straight edges. So we can tell right off the bat, this first thing here is not a polygon. We got crosses here that represents not a polygon. This next one is not closed. This is good. This does not have straight edges, and this is not closed. All right, let's write the name of each figure. Use the word once. So this is either triangle, square, rectangle, circle. This one is a circle. This one is a rectangle. This one here is a square. And this one here is a triangle. All right, consecutive. So consecutive means following in order without interruption. Another word we use for consecutive might be sequence. So for example, the numbers 2, 4, 6, 8 are consecutive even numbers. They occur in the next order. Some non-examples, 1, 3, 2, 5, 4 are not consecutive numbers because they're not in the right order. All right, so draw a line from each sequence of letters in column A to the next consecutive letter in column B. So what letter comes after L, M, N, O, P? What letter comes after V, U, T, S, R? And then how about A, C, E, G, I? Okay. Next problem. All right. So label the parts of each triangle below. So here's a square. Okay. So in a square, we call each of these sides and we label them S. So therefore, the perimeter of a square is 4S and the area is S squared. So you might use these formulas to find the area and the perimeter of a square. All right, in a triangle, we usually call the sides A, B, and C. And then the thing that's perpendicular to one of the sides is called the height. So the perimeter will be the sum of the three sides, and the area will be 1/2 the base times the height. And very important, the base and the height have to be perpendicular to one another. All right, in a rectangle, we usually call one the height and we usually call one the base. So the perimeter will be 2 bases because there's 2 bases, plus 2 heights because there's 2 heights, plus the area, which is base times the height. And then here's the circle. The stuff that goes all the way around is called the circumference. The thing that comes from the center out is called the radius. The full thing that goes through the center is called the diameter. So the circumference is given by the formula pi times the diameter, or 2 pi times the radius. And the area is pi r squared. All right, so finding the perimeter of a rectangle. So if I want to frame a picture that's 5 inches by 7 inches with a 1 inch wide frame, what is the perimeter of the picture? So the picture we know is 5 inches by 7 inches. Which formula gives me the perimeter of a picture? Well, since this is a rectangle, okay, 5 by 7, I'm going to use this formula, P equals 2B plus 2H. So use substitution, P equals 2B plus 2H. This equals 2 times my base, which is 5, plus my height, which is 7. So that equals 10 plus 14, which is going to equal 24. Therefore, the perimeter of the picture is 24 inches. Okay, let's find circumference. So our students tried to plug this in. What's wrong with this problem? Well, obviously, the diameter is 24. Okay, so 24 pi, books okie. Okay. Circumference, oh, I see what happened here. So the problem says that the radius was 24 meters. The student drew it as the diameter, so that was the problem. So the student used the diameter of 24 meters instead of a radius of 24 meters. So let's find the correct circumference. The circumference is equal to 2 pi r. So C equals 2 pi times my radius of 24. So C equals 48 pi. And that is my circumference. Okay. So let's find the perimeter and the coordinate plane. So the first thing we're going to do in this problem is graph a quadrilateral with vertices at -3, -3. So let's plot the point. 1, -3. Let's plot that point. 1, 4. Let's plot that point. And -3, 1. Let's plot that point. So we're going to connect the dots. All right, and here is the perimeter. So first thing we're going to do is find the lengths. So let's label all these points here. So this point here is J, this point here is K, this is L, and this is M. So the length of JK along the bottom is -3 minus 1, and we get 4. KL is going to be 4 minus a -3. And that's going to give us 7. JM is going to give me -3 down here minus 1, which is going to give me 4. And then ML is not a straight line, so I have to use the distance formula. So the distance formula is going to be 1 minus -3 squared plus 4 minus 1 squared. So 1 minus -3 is 4. 4 minus 1 is 3. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is 5. So to find the perimeter, we add up all the numbers we just found. 4, 7, 4, 5, and we get 20. So the perimeter of this figure was 20. All right, how do we find the area of a circle? So if I know the diameter of a circle is 14 feet, let's label that. And I know the radius is 7 feet. So label the diameter and radius of the circle. We're going to use the formula. So A equals pi r squared. A equals pi times 7 squared. So A equals 49 pi. Therefore, my area is 49 pi feet squared. And remember, you should always use your units. All right, the area addition postulate. This is actually an interesting postulate. So it says the area of a region is the sum of the areas of its non-overlapping parts. So it's very similar to our segment addition postulate, and it's very similar to our angle addition postulate, where they all state that the whole is equal to the sum of its parts. Very important concept that we go over in geometry a lot. So what that really means is here, in this figure, we might need to find the area of an irregular shape. So one way we can do that is actually by dividing an irregular shape into regular shapes that I know how to find the area of, okay? So here's one way we could divide this, okay? Let's try this problem here. So how might I divide this? So let's take a look here and let's do this. So this is area 1, okay? We could also divide this way, and this could give me area 2, and this could give me area 3. I could have also done it this way, and here's area 1, and I could have done it this way, and here's area 2, and then here's area 3. All right. So all of these would give me different areas of how to separate. And I just have to add up those areas and I could do it. Okay, so underline the correct words. Areas will always involve square units. The circumference is the same thing as perimeter and will involve units. The formula 2 pi r relates the circumference because it involves units. All right, and that is this section.